Welcome to clickmyproject.com. Ear and fingerprint biometrics for personal identification. Here we propose the method to identify the person by the fusion of ear and fingerprint features. Here two algorithms are used for feature extraction. First is edge interaction point detection (EIPD) for fingerprint, and gabber feature extraction is used for ear. Initially we remove the noise from the image by using the Gaussian filter. Then we detect the edges of the finger and the ear for extracting the feature values. The identified edge is passed to the feature extraction by EIPD. Horizontal and vertical imaginary lines are drawn on the pre-processed image. Samples of the mask used for identifying the ridge ending and bifurcation point. Although the process seems to be simple, it is necessary to consider the elimination of false detected points. Gabber filters are similar to those of human visual system, and they have been found to be particularly appropriate for texture representation and discrimination. It is a linear filter used for edge detection. The distance is calculated between the database and the testing image. The minimum distance index is predicted as a identified person. This is the overall flow of our project. It consists of two input images, ear images and fingerprint images. The both input images are pre-processed using the Gaussian filter. In pre-processing method, Gaussian filter is used to remove noise from the input test images. It is often disabled to be able to perform some kind of noise reduction on an image or signal. The Gaussian filter is a non-linear digital filtering technique often used to remove noise. Such noise reduction is a typical pre-processing step to improve the later processing. Gaussian filtering is very widely used in digital image processing. The computational effort and the time is spent on calculating the Gaussian of each window, because the filter must process every entry in the signal. For large signals such as images, the efficiency of this Gaussian calculation is a critical factor in determining how fast the algorithm can run. Gaussian filtering is one kind of smoothing technique. As in linear Gaussian filtering, all smoothing techniques are effective at removing noise in smooth patches or smooth regions of a signal, but adversely affect edges, often though at the same time as reducing noise in a signal. It is important to preserve edges. Edges are of critical importance to visual appearance of images. For example, for small to moderate levels of Gaussian noise, the Gaussian filter is demonstrably better than Gaussian blur at removing noise, whilst preserving edges for a given fixed window size. The next block is edge detection. In both finger and ear, we extract the edge detection. For this, initially we convert image into binary image. Adaptive threshold algorithm is used as a binarization. First, we choose the seed point in the image. From that point, we find the similarity pixel to the CT image. Finally, this similarity pixel will be segment from the CT image. The next is feature extraction. Two feature extraction is used. Gabber feature extraction. First we go for gabber feature extraction. We extract the gabber feature for the input image. Gabber filters are similar to those of human visual system, and they have been found to be particularly appropriate for sector representation and discrimination. It is a linear filtering used for edge detection. The next feature extraction method is for edge interaction point detection. The proposed edge interaction point detection system provides an enriched feature points. By EIPD, M horizontal, N vertical imaginary lines are drawn on the pre-processed image. Samples of mask used for identifying the ridge ending and bifurcation point. Although the process seems to be simple, it is necessary to consider the elimination of false detected points. A more refined second-order edge detection approach, which automatically detects edges with subpixel accuracy, uses the differential approach of detecting zero crossing of the second-order directional derivative in the gradient direction. The next block is recognition. Here the recognition process is identified by the weighted matching. The equivalent distance is computed for the test feature with the database features. The similarity is identified between the features. Finally, identified image is displayed. Open the source code folder, select main.m file and select run file. From the window, select the train features and choose input image from the dataset. Select any one of the fingerprint images from the fingerprint dataset. If we choose the fourth image from the fingerprint, then we also choose the fourth ear images from the dataset. This is the fingerprint image, fourth image, After that I can apply pre-processing for the input image. This is the denoised image. After that I can extract the region of interest. This is a region of interest. After that I convert into binary image. This is the binary image, and then morphological operations are applied for the input image. This is a thinned image, and then extract the Gabber features for the fingerprint image. This is the Gabber filter, the orientation values, and go for the next guy window. This is the ear training features, and select the input image. I have chosen the ear images, fingerprint as the fourth image, and also choose the ear image as the fourth image. This is the fourth ear image, and the pre-processing is applied. This is a denoised image. After that detect the edge from the input for the input image, and extract the EIPD features for the input image. This is the EIPD feature values. This is the edge interest points here, and I calculate the fusion matrix for here. I will combine the Gabber feature and EIPD feature values. After that I recognize the recognition. The identity person is 4, and the fingerprint image is also displayed here. After that I calculate the performance analysis. In performance analysis, sensitivity, specificity and correct class is calculated. This is the false rejection rate and the false acceptance rate. This is the cumulative match characteristics curve, and it is a ROC region of curve for classification, false positive rate versus true positive rate graph here, and this is a sensitivity, specificity and correct rate of our proposed algorithm. From this I conclude that our proposed algorithm achieves 100% accuracy than the existing method. Thank you.